Hi everyone, welcome to our video on sketching a curve based on given information. So in our previous problem, we did the whole first derivative test, the whole second derivative test, and some other pre-calc stuff to get this sketch when we also just plugged it into a calculator as well to get it. So we can bypass a lot of stuff with the calculator. Where the calculator failed was knowing these square roots though. Okay, so that's the one problem it could have. All right, but otherwise, the calculator does a very good job at sketching. With this, it's just kind of making us make sure we know the rules for sure and not be able to just plug something in. So here it gives us a list of information, and we have to know what it means, and then afterwards make our own sketch. Now, the sketch varies. I always just say attack the problem with whatever method you want to use, and then just double check that all of these properties are going to be satisfied eventually. So you might have a sketch to start off, and maybe something's a little off. Well, we could always fix that. All right, and all it is just making sure the main thing is remembering all of the first derivative info and all the second derivative info. All right, so we have our our number lines that can also help us along the way. All right, so let's see how this problem goes. So in this example, it says sketch the graph of a single function that has all the properties listed. And then it's got a lot of these properties. All right, and you can start wherever. It doesn't have to be top to bottom. Notice this here, these are involving the first derivative. So I'm going to kind of group a little bit. It looks like these involve the second derivative. Okay, and with our second derivative, remember this is telling you about concavity. There's my two friendly people here. So this is how the concavity is of f. And then it says f is continuous at -4. Oops, I didn't want to plug that in to -2. Okay, so it gives us that interval. It tells us something about our derivative, our first derivative setting equal to 0. So that's using this here. There's probably a turning point. So that, or it could mean we have there's relative extrema occurring there. Okay, so at x equals 1 and x equals 5. Let's go ahead and mark that. And then f of x has x-intercepts at x equals 3 and x equals 7. So it tells us about intercepts. This we could just go ahead and plot. So I'm going to take care of this one right now. F of x has x-intercepts at x equals 3. So 1, 2, 3 right there. And 7. So 4, 5, 6, 7 right there. Okay, so there's 2 points. So that's plotted. Okay, so that one I've got. All right, and then it tells us all of this other stuff. Well, here's what I'm going to do. Let's go ahead and keep this in black ink, and I'm going to make a number line with it. So I'm going to take the same strategies that I have. Okay, so it looks like -4 is important to us. -2 is important to us in this first derivative. It looks like so -4, -2, -2 is already marked. 1 is important, and then 5. And then 1, 2, 2, and 5. Oh, I have a 2. Let's get that in there as well. So I'm just making sure. So I'm just making sure I plotted all of these x coordinates. It says it's continuous on -4 to -2. So based on this statement here, I'm assuming there's nothing left of -4. So I'm just going to scribble that out. All right, and then this is our x information. And then I usually show here's our f prime. And then here's our f. Okay, and it tells us the signs. Remember, this means that if it's greater than 0, this is saying f prime is positive. And then being at less than 0 would be f prime is negative. Okay, so let's go ahead and start marking those. So from -4 to -2, they said it's greater than 0, so positive. And then -2 to 1, positive. And then from 5 to infinity, positive. Okay, so that looks good. And then it says it's less than 0 on 1 to 2 and then 2 to 5. So negative and negative. All right, and then that tells you about f. So it goes increasing, increasing, decreasing, decreasing, increasing. So it looks like there's a relative max at 1. Relative max, which matches this information right there, and there's a relative minimum at 5, which matches that information right there. Okay, so that's good to know about. And then now we know how it's going to go. So it looks like, so let's go 1, 2, 3, 4 like that. So it should, so I'm just getting my x coordinates ready. So it should increase, increase, then decrease, decrease, and then increase one more time. I'm going to do this with the dots. So -4 to -2, I'm just going to go ahead and do like these little dot holders. Actually, let's do it like this with a highlighter that I can erase eventually. Okay, so I'm going to use this highlighter to show this is where -2 is, and then 1, and then I didn't really give myself too much room, but there's 2, and then 5, so 1, 2, 3, 4, 5, right there. So I'm breaking it up, so during this portion right here, so this is where it should increase. From -2 to 1 is where it should increase. And then it should decrease in that little interval, should decrease in that little interval, and then increase in that interval. Okay, so that's all I'm doing that highlighting for. All right, so next thing, let's show this one. I'm going to do this one in blue, kind of right next to it. Okay, and this is our second derivative information, and let's plot what we currently have. It looks like -2's important, -1's important, and then 2's important, -4 is important, and then -2 got that, -1 got that, +2 got that. Okay, so I think everything's there. And just like before, based on it being continuous on this interval, I'm going to just kind of scribble this out and say I think I'm only concerned about rights of -4. Okay, and now I've got my second derivative. And then my f, this one I'm going to do in green, f. Okay, and that's using our friends that I circle, that I have right here, my smiley faces and frowny faces. All right, and then now I'm going to plug in some x coordinates here. Well, I don't actually plug them in. I have this information, and I'm just going to mark where it is positive and where it's negative. So remember, where this is greater than 0 is where it is positive. So f prime of x, f double prime of x being greater than 0, from -2 to -1. So I'm going to mark positive there. And then 2 to infinity, so positive there. And then from -4 to -2, negative. And then from -1 to 2, negative. Okay, so then I know it's concavity, where it's negative is concave down, positive concave up. So it's something like that. Okay, so that's these starred in the blue number line with our green colors though. Okay, and after that, I just now want to piece everything together. All right, so nothing left of -4. It looks like -2, I would have to make sure I have a change in concavity. Okay, but let's see how this is going to work. All right, so from -4 to -2. So now I'm just going to kind of put these together at the same time. Okay, so from -4 to -2, I'm really just focused on the red. It has to increase. Now, it doesn't really tell me anything else about it. I'm just going to have it increase. Let's say, let's do an open dot here, and then it increases something like that. And then it should be concave down. So let me maybe make that a little bit curvier like that. That's concave down until I get to -2. And then it says it needs to change to be concave up. Okay, so I'm going to go and say something like that. That's concave up. And it's still increasing. From -2 to 1, it stays to increasing. Okay, so maybe, let me go back and erase it a little bit because it looks like I'd go too high. So concave up, something like that. Okay, so notice it is concave. Let me use green for my concave down. So this is concave down, and I'll continue using black for concave up. Okay, and that's where it is increasing, so everything's looking good so far. All right, and let me go back to this. It said it was continuous. Oops. Okay, so now I got to go. So all it is, so this is not a one straight shot for an answer, I guess, unless you're lucky. But I need to verify my f of x being continuous. It said it was not continuous at -2. So maybe instead of the highlighting, I should also make a note. So at -2, I should have a discontinuity. Discontinuous. And also at +2. So at +2, also a discontinuity. So I'm just marking my the yellow to show I have discontinuity. Okay, so and then let me go ahead and just put an open dot. Like that. And so it should have been discontinuous. And so now let me continue to draw. All right, so after -2, from left to right, I have concave up, and it needs to increase until I get to 1. So let's go ahead and put that down here, and then concave up till 1. Okay, so that looks good. Okay, so that's that. And then let's see what else we've got. So after 1, it needs to change directions. It needs to start to decrease. Okay, so that's fine. And also at... Oh, wait a minute here. So from -1 to -2 to -1. Okay, so again, not a straight shot. -2 to -1, it should have changed concavity. So I'm looking at lots of things all in once in this problem. So that's why they're tricky. That's why I'd say use a pencil and get ready to erase. Okay, so from -2 to -1, it's only concave up for just a little bit. And then from -1 to +2, it is concave down. Okay, so it's concave down. So there's concave down. It still needs to increase from 1 to 2, or from -2 to 1, from -2 to 1, it needs to increase. So I'm following that red there. So it is going up. But at 1, it will need to change to go downward, and I need that relative max. So I've got something like this, maybe until 2, where there's a discontinuity. Okay, so and at 2, a discontinuity means I'm just going to do an open dot. Okay, so there's that. So again, all I'm going to do is make my sketch the best I can with both of these pieces and all of this information, while also at the very end just double checking that they will all be satisfied. Okay, so let's continue seeing everything. All right, so I'm currently at +1, and I need to keep going right. Well, from 1 to 2, or no, I'm already at 2, sorry. I'm at 2, I've done the concave down portion, and then now I'm at 2, and I need to continue going down. From 2 to 5, I am decreasing still. So from 2 to 5, so maybe somewhere about here, I'm decreasing. But I need to be concave up, so that's looking good. And then at 5 is where I would have a relative minimum. So 1, 2, 3, 4, 5. So let's say the relative minimum's about there. Okay, and this is still concave up, and it needs to stay concave up. So eventually I need to turn around and hit that x-axis, and then it stays continuous forever. Okay, so this is a guess of a graph. Okay, now that it's fully sketched, okay, you can see how kind of difficult it is to go back and forth with all of the information to make the sketch. Let's verify that all of these pieces are correct. Okay, so all I'm going to do first, so now I'm just going to verify. All right, so let me do it in purple. Okay, so I'm going to go through all of these and put a check mark to make sure they're good. Okay, so still this referred to the star. Well, is it increasing on, so I just want to see, is it increasing here? Okay, so it's going up. It's going up. Yep, to +1, and then at +1 it goes down. Yep. And then from 2 to 5 it's going down. Yep. And then from 5 to infinity it's going back up. Yep. Okay, so these are satisfied. Okay, and then double check, did I have a relative max at 1? Yeah, it doesn't look the best. I'm going to put a big dot there. Yeah, it looks like that's supposed to be the peak. Yep, yep. Okay, so that is met, and then the relative minimum right there, yep, that's also met. Okay, so everything's good about the first derivative. Now the second derivative, I'm just checking for concavity. Okay, so from -4 to -2, is it concave down? Yep, that part is. So this one's good. And then from -2 to -1, is it concave up? So -2 to -1, yeah, that's that portion right there. Yep, that's concave up. Then from -1 to 2, it's concave down again. So here's -1 to 2. Yep, that's a frown. That is concave down. And then from 2 to infinity, it's concave up. So here's 2. Yep. Okay, so that's all good there too. All right, so all of these are satisfied. And then is it continuous from -4 to -2? Yep. From -2 to 2, yes. And then 2 to infinity, yes. All checked out. My relative extreme already met. I used the number line to help with that, so yes, that was good. And then the x-intercepts at 3 and at 7, yes. Okay. All right, so you could have bumps along the way, okay, just like I did. But that's okay. That's supposed to happen. Again, if you get it on the first try, I mean, that's either there's not that much information and it's an easier problem, or you're very lucky. All right, so take your time with it. Go through the purple, I think, is the key element to it all. Make sure everything checks out. And then if it does, then you're done. Awesome. Okay, and you could have answers that vary. So it doesn't have to look exactly like this. It could be different. Okay, so that's fine. But as long as these conditions are met, it's good. Okay, so let's put a pause. I'm going to do this one on a different video. If you want to try it on your own, go for it. But let's take a break because these are long problems. Okay, so let's take a break. I'll see you next time. Thanks for watching.